We're going live. We are now live. Reminds me of something Bill O'Reilly used to say. We'll just do it live. All right, so we're going to talk about confidence intervals, and maybe I should be a little bit more specific. Hopefully, I can grab a little bunker marker. Got all my white ones today. We're doing confidence intervals for the sample mean. Okay? First of all, let's talk about the requirements. Okay, number one, the data comes from a simple random sample. Okay, now, just so you know, I'm going to be asking you guys on your final project, by the way, who started collecting data? That's what I was afraid of. Okay, you can do it next weekend when you got your fall break, right? That'll be fine. Instead of coming to class, you can collect data. It's really interesting. We got this possible impeachment going on. I wonder if attitudes have changed since last year. Okay? So that'll be an interesting thing to think about. But data comes from a simple random sample. Now, I want to mention something. Okay? This is the requirement. I have asked you to do a stratified sample, a cluster sample, those kinds of things. Technically, those break the rules. Okay? So in your when you're doing your project, say, well, technically this isn't a simple random sample, we're breaking the rules, but I want you to do it anyway. But know that you're breaking the rules when you do that, okay? Number two, okay, now I'm talking about a mean. I'm not talking about a proportion, but the data comes from a normal population with n greater than or equal to 30. Okay? Now, we're talking about means. Remember, what does the rule apply for proportions? NPQ greater than 10, right? So I'm only talking about means with this requirement. Okay? And rule number 3, sigma is known. Okay? Now, in real life, sigma is usually not known. Okay? This is a big assumption. Okay? We are going to learn, in fact, this is going to be your last easy test. When's the test again? Tuesday in class, and Monday, Tuesday, or Wednesday in the testing center for the computer part. Okay? Now, we are going to learn a different test when sigma is not known. Okay? Part of the thing that's going to make the next 2 tests after this last one hard, it's going to be way harder than this one, is because I'm going to give you about 4 or 5 different equations to do the same thing, and you got to pick the right equation. Okay? So paying attention to these requirements are going to become very, very important. Okay? We'll talk about that more after fall break on how do you pick the right test. All right, so typically, I'm going to talk about confidence intervals in general. In general, as opposed to these specifics here. In general, the confidence interval is of the form your point estimate plus or minus some sort of a margin of error. Okay? So a point estimate would be, so let's talk about that. We haven't used that terminology, although we've talked about it in different terms. Okay? Point estimate would be something like an X-bar, or it would be something like a p-hat. What is X-bar again?
The mean of the sample.
It's your sample mean. I'm sure, Maria, you always give the right answer. You always whisper. Okay? What's p-hat? That was one we haven't talked about too much. Let's see if you can guess what it is. Population mean? No.
NPQ. The NPQ.
What do you think on NPQ, what does the P stand for? Proportion. So this is going to be your sample proportion. Okay? So your point estimate always refers to the sample. Okay? And then it's going to be plus or minus some sort of the margin of error. Okay? Now, let me give you, so this is the first of many formulas you're going to have to be able to distinguish. Now, remember, you don't have to memorize the formulas, but you have to be able to distinguish and say, which one do I use, okay? We're talking about a mean with sigma known. Okay, the formula is going to be x bar plus or minus z sub alpha over 2 times sigma over the square of that. Okay? That's the formula you're going to use all chapter 16. Okay? So, so that's what we're going to use. So this is your point estimate. X bar is your point estimate. This piece here is your margin of error. Okay? That whole thing. Now, we've talked about the 68, 95, 99 rule. You guys remember that still? Tell me what it is, Emma.
Sorry, I was writing.
You're
The
right.
68, 95. Oh, that's the empirical rule where
The empirical
68.
rule, can you describe it to me? Can you draw it for me if I put it on this next test?
yeah.
I put it on the last test, didn't I? Still need to know it.
So 68% of sample data falls in the middle.
Yeah, within one standard deviation,
Yeah.
right?
And then within two
One standard deviation, you've got 68%. And 2 standard deviations, you've got how much?
95.
95%, okay? Okay, so if you've got 95% within 2 standard deviations, how much do you have outside of that?
5%.
You've got 5%, okay? So think of this area in black here. Okay, we talked a little bit, remember last time we talked about, I know you've got a question here. Go ahead and ask your question.
Just real quick, I just can't read what is below the Z.
Yeah, by the Z.
By the Z.
Z sub alpha over 2, that's what I was just trying to answer, what alpha over 2 is, okay? Now remember last chapter, we said, how do you decide if something is significant? Typically. Yeah, we said the alpha equals your significance level. It's most often alpha equals 0.05. So something happens 5% of the time or less, okay? So one way to think about this is, okay, if I go 2 standard deviations out here, okay, I've got half of my alpha here and I've got half of my alpha here. Does that make sense? You can think of your significance level as the probability you are wrong. If you're wrong 5% of the time and you're right 95% of the time, how many of you say that's a pretty good score on the test? Okay? So that's what we're saying, okay? Now, the whole idea with a confidence interval, and this relates to that problem on the test that I took, or on the homework that I took off, okay? The idea here is, okay, you've got a population mean of mu, okay? Typically, you don't know what mu is, okay? So you're going to do an X bar. And it could be lower, it could be exactly right on, it could be higher, right? So the idea here is, well, I don't know what mu is, but I do know what X bar is. This might be my X bar. And the idea here is if I go out, say, 2 standard deviations, -2 sigma, +2 sigma, I'm going to be right 95% of the time. And hopefully my mu, the true mu, is within that interval. okay? And so the idea here is if I go out, typically, it says 95%, just like alpha 0.05 is the probability you're wrong. Your most common confidence intervals are going to be 90%, 95%, 99%. Those are your most common confidence intervals we're going to do. And I would say, once again, 95% is the most common. So it's related to your alpha. If you have an alpha of 0.05, you're going to be right 95% of the wrong. 95% of the time, you're going to be wrong 5% of the time. Okay, does that make sense? All right, so let's see. So that's the kind of the concept that's behind a confidence interval. Okay. So let's talk a little bit more about the margin of error. Okay. So that's this piece here. Okay. So we're going to have a level of confidence. And I'm going to say typically 95%. Okay? Now, now the question is, now I'm going to get away from means for a minute. Okay? But since this is related to your we'll talk a little bit about your margin of error. Okay? Now, you probably hear typically, and I know impeachment's kind of in the news lately, so let's talk a little bit about impeachment. Okay? I think I recently heard it was 51% of Americans support impeachment of Donald Trump. Now, they often talk about plus or minus, typically it's 5%. Okay? So the idea here is, it's always easy. I should always do polls first because I think they're easier to understand. I'm going to give you another formula that you're not going to need for this chapter, but I'm going to give it to you because it relates the same way. Okay? This is for a proportion, confidence interval for a proportion. Okay? Now it follows the same basic format: point estimate plus or minus your margin of error. Okay? And that's going to be p hat plus or minus z sub alpha over 2 times the square root of p cubed divided by n. Okay? Now you don't need to know that for tonight's homework. You will need to know it for later on though. Okay? So I'm giving you a preview of a future chapter.
Is PQ over what?
PQ divided by n. Oh, I can't see it on there. There it is. Okay? That's the formula right here. Okay? Now the reason why I want to mention this is because I think polling is a little bit easier to understand. So for example, you might say that 51% of Americans favor impeachment, and the margin of error is plus or minus, depending on your poll, 3%, or plus or minus 5%, depending, and it depends on a few things. Your margin of error depends on your level of confidence. 2, it depends on your sample size. And it also, 3, depends on the standard deviation of the population. Okay, so those are the 3 things that your margin of error depends on. Now, some things to think about. As your confidence increases, your margin of error also increases. Okay? As your sample size, I'm just going to bring that size, increases, your margin of error decreases. Okay, now sometimes these are a little bit hard to figure out. Okay, so let's say, for example, that I'm 95% confident that, and I'll use the poll because I just heard that yesterday, 51% of Americans support impeachment. Okay, and the margin of error is, let's say it's 5%. Okay, now the first question I want to ask you is, if these numbers are correct, let's assume that they are for now, for what we're doing, okay? Sorry, can't see that very well. Okay, can we safely say that a majority of Americans support impeachment?
No,
No, why not?
because the margin of error,
Because of the margin of error.
because if there was the error, then it would be 46%, right?
Exactly correct. You went exactly where it could be as low as 46%, and it could be as high as 56%. Okay, so typically, I think on the news, this is what they usually say. You say 51% plus or minus 5%. On your test, I'd rather you wrote your margin, your confidence interval as 46% to 56%. Okay, so even though, and this is what's interesting about the news, because I can almost guarantee you, I'm pretty sure I heard it on Morning Joe this morning, that they said a majority of Americans support impeachment. Well, that's not exactly true. It could be as low as 46%. It could be true. It could be as high as 56%. We don't know. The problem is we don't know what the true proportion is. We're making an estimate. Okay? Now, my question to you all, okay, another thing that they usually don't tell you, if they don't tell you, you should assume that it's 95% confidence. Okay? So now let me ask you, what if I wanted to be 99% confident? I want to increase my confidence level. I want to be right 99% of the time rather than 95% of the time. What's going to happen to my margin of error? Is it going to get bigger or is it going to get smaller?
Bigger.
Why is it going to get bigger? Because I wrote it on the board.
Because you're getting like
I shouldn't have written it on the board.
closer. I thought it's so funny. Like you're
Does that
getting
make
closer
sense
to
why that is the case? Because how many, even though I wrote it on the board, what would your intuition have said? We probably would have said it would decrease, okay? But if I want to be really confident, I want to be right more often. Let's say I wanted to improve my confidence level to 99%, okay? Let me rephrase here. I am, in fact, I'm going to rewrite your confidence statement. This is how I want you to write your confidence statement. Confidence statement. Okay? And I'm going to write the first one here. We are, and then blank percent confident that, and then whatever you're measuring. So the proportion of Americans to support impeachment. Okay, I'm going to fill in that blank because that's what we're talking about at the moment. Is between, and then I want you to put it in parentheses, the low number first and then the high number. Okay? So going back to this example here, we're 95% confident. So 95% confidence that the proportion of Americans that support impeachment is between 46% and 56%. Okay? So this is the basic form I want you to do. So tell me how confident you are. Tell me what you're measuring. and then put the confidence interval again. Okay? So that's what I'd like to see on your test is a confidence statement. Yes,
Does it have to be we are, or would it say I am? Like,
we are, I am, whatever.
okay.
Okay? I'm not picking on that. Yes,
So it's the confidence, it's not related to the statistic, it's more of your own intuition kind of thing.
is the confidence level related to the
Yeah.
statistic? Yeah, it is. Because the idea here, I just want to go back to this picture here, okay? Now I used X bars here. I'm kind of mixing my X bars and my P hats. All of your homework problems are going to be X bar, okay? Rather than P hat. But the idea here is, let's pretend that X bar is 51%, okay? The true mean is 51%. But I don't know if mine's low or high. So yes, my confidence level is related to my statistic in that I want to be right 95% of the time. Okay? Did I answer your question or maybe not?
So I still don't understand why is it that when you're 99%, your
Okay.
confidence
That's where I was
99%.
going. I'm going to answer it this way. Okay? So now I want to improve my confidence level from 95 to, hey, you know what, I'm going to go for the gusto. I want to be positive that I'm right. 100% confident. I am 100% confident that the proportion of Americans who support impeachment of Donald Trump is somewhere between 0 and 100%. Prove me wrong. Okay, what did I just do with my margin of error? Made it as big as possible, right? Okay, so if I want to be more confident, if I want to be 100% confident, make your margin of error ginormous. Okay, so if you want to improve your confidence, you make your margin of error bigger, and then you're going to be right more often. I might be 50% confident that it's between 75 and 80%. I'm not very confident. Okay, I could be wrong, I could be right, I could be wrong. Might be 10% confident between 90 and 95%. Okay, so if you want to keep your confidence, if you want to get your margin of error smaller, you can decrease your confidence. Okay? Yes.
So how much does it change, guys? So like when we did the 95%, we did like 5% more, 5% less. If you were to go like 99%, like how much more do you do on each side?
That's a great question. Okay, I was just making up a bunch of numbers, but we're not going to make up just numbers. Okay, so really good question. Now let me show you as I answer that question. Okay, maybe I should have left you to see your formula sheets. I know that's a really bad angle, but if I open up my formula sheets here, here it is. Okay. Now let's go to the normal distribution. Okay. Up to now we've been looking at this here. This is what we're going. These are the most common critical values for confidence. So I've got 90% confidence is a critical value of 1.645. 95 is 1.96. 98 is 2.33, and 95 is 2.575. Okay, so these are probably the four most common confidence intervals you're going to be. Now, the problem is I can't totally answer your question because your margin of error is based on what three things? Level of confidence, sample size, and the standard deviation of the population. Okay, now. I want to get away from polling because you're not going to see any polling questions in chapter 16, okay? But the idea here is, let's see, do I have a good example here? It probably would be helpful to do an example and then that might help answer your question. Okay, let me just do an example. Okay. Can I erase this? All right. So let's say, this actually kind of happened in my neighborhood. But these numbers are gonna be off, okay? So neighbors think people are speeding and want evidence to give to the police. Okay? The speed limit is 55 miles per hour. Now let's make it 50. 50 miles per hour. Okay? No, heck, we'll leave it at 55. 55 miles per hour. They find 12 cars have a mean speed of 59.62 miles per hour. The police tell them the standard deviation is 8 miles per hour. Find a 90% confidence interval. And is there enough evidence of speeding? Okay? So how do we do this?
We first want to change it to like a normal sentence.
Yeah. Oh, and by the way, I'm sorry. Trying to sell my mom's house and real estate agents call me all the time. Anyway, say that again, Arthur.
So you have to change it to like a normal standard distribution.
Okay, so we're assuming this is normal distribution.
Oh,
This doesn't say that in the problem, but let's assume. Is my sample size big enough?
So when do you know if it's supposed to be more than 30 or 10?
Yeah, that's a good question.
so I think
That was my question. How do you know it's supposed to be more than 30 or more than 10?
So more than 30 is a probability, right? So it's
More than, no, probability is the wrong word. Okay, let's go through here again. Neighbors are, in fact, here's what I would recommend. Anytime you're doing these, remember how on the problem today, I wrote down all the numbers you need to know and what letters they are associated with? Let's go through this. Neighbors think people are speeding, want evidence to give to the police. The speed limit is 55 miles per hour. What's 55? What letter should I use for that? Bueller? 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 Have you guys ever seen Ferris Bueller's Day Off? First semester I ever taught I had a Bueller in my class. What do you think, Jose?
I don't know.
You want to phone your friend Colton? What do you think, Colton?
Is it, I don't know, I don't think it's anything.
It
It's not
is.
like the
It's
standard
weird.
deviation, it's not like the new, it's not.
Not the view?
I can assign a variable to it, but I'm guessing you don't want to subtract the mean from, or that, yeah, you're gonna start subtracting the mean from that number. in the problem.
So it would
The
be.
mean is 59.62.
Which mean? Okay, so we got something, we know, okay, we'll do what we know. Something is 59.62. What is that?
That's-
X bar.
Sigma.
Sigma?
No, it's the mean.
It's
X
the,
bar?
yeah, X bar.
Should we vote?
No.
No? I don't wanna vote. Who says it's X bar? 1, 2, 3, 4, 5, 6, 7, 8, 9, that's definitely the majority. Who says it's something else? Okay, it is X bar, you're right. Okay? Okay, so if that's X bar, what do you think 55 is? The mu? Who thinks it's mu? 1, 2, 3. Who thinks it's something else? 1, 2, 3. Oh, we got a tie. Okay?
Laser.
Nothing else for speed.
It's mu. It's what people are supposed to be doing.
Oh,
The population is supposed to be
that's not the real.
driving the
no.
speed limit, right?
That's
Back
tricky, 'cause I
neighborhood.
feel like
That
I
is
would not
tricky.
guess that.
We don't know if that's what it is, but that's what they're supposed to be.
That's a fast one.
That's what the population is supposed to be doing. So we're gonna call that the mu. We're trying to find evidence to see if that's right or wrong. Okay? Now they are speeding, right? The question is 55 in that interval? We're gonna find out.
90%.
Okay? All right, so 55, they find 12 cars, something's 12.
And,
What'd you say?
and
N is 12. 59.62 we already got. Please tell them the standard deviation is 8 miles per hour. Which standard deviation?
For the population.
We're assuming the police know what they're talking about, right? So we're gonna call that a population, so I'm gonna use the letter
this is sigma, is that how you say it?
sigma. Okay? Find a 90% confidence interval. So my level of confidence is 90%. Therefore, my alpha is what?
10?
10% or 0.10. We usually write alpha as a decimal, okay?
Okay.
Is there enough evidence for speeding? Okay, what's the formula I need to use for this?
I'm pretty sure.
What is it, Carson?
I'm pretty sure I'm gonna say it wrong. But
Okay.
it's X bar
X bar
plus or minus
plus or minus
Z.
Z, so alpha over 2.
Okay. And then the sigma over the square root.
Sigma over the square root of that, that's correct. Okay, so let's start plugging our numbers in. X bar is what, Maria?
59.62.
59.62 plus or minus. Now I need my Z sub alpha over 2. In order to find that, I've got to look it up on my chart. My chart says I'm looking for 90% confidence. What's my critical value? 1.645. Okay, so I'm going to put 1.645 here. Let's go back to my board. Okay, 1.645 times sigma, which is 8 miles per hour, divided by the square root of 12. Okay, now let me show you how to do this on the computer, but you should know how to do this on your calculator for the quiz on Tuesday. Okay?
So we're gonna have a quiz before the exam, or?
Oh, that's right. I
Can
guess
you
we're
just like
not.
send us the quiz?
These are my other class. We're not gonna have a quiz on Tuesday. We're gonna have a test on Tuesday. Okay, but we will spend 15 minutes doing a review of that. Okay? All right, so as we go back here, okay, equals 59.62, and I'm gonna do the minus first. So here's how I recommend doing on your test. You're gonna want to lower and you're gonna want to upper. And upper equals 59.62 minus 1.645 times 8 divided by the square root of 12. Okay? So I've got 55.82. I'm going to copy and paste this, and then I'm going to change that minus to a plus sign. Okay? So now I've got that information there. Okay, now I want Arthur to give me a confidence statement. Are you confident enough to do that?
Let's see, so,
I erased it though, didn't I? You'll have to look at your notes.
so if we use the standard deviation as 8. Well, this is right, and then it'd be.
Okay, remember that confidence statement?
So would it be 90% confident that?
We are 90% confident that
Okay.
The cars, like, speed, I guess.
cars are traveling between
We lost the thing, but
oh yeah,
it's fine.
It's 55.82.
55.82, comma,
63.4.
63.41 miles per hour. Okay, now the second question, and this is the last question. Is there enough evidence for speeding? How fast are they supposed to be going? 55. Is 55 in my interval?
No.
It's like on the lower end.
It's supposed to be 55.0, right?
Oh, yeah.
Is there evidence for speeding?
Yes.
Come on, police, start giving tickets. But are they gonna give tickets if you're over 0.82 miles per hour or something
I think they don't give it to 10% over.
Yeah.
But
Depends on what state you live in.
I think the first mark on CDA is 10%.
Where are you from?
Texas, that's all I know.
Texas, see, Texas is 10%. Cause I'm like, they don't do that in Utah.
Yeah.
Okay? All right, so is there evidence of speeding?
Yes.
Technically, yes, but it is kind of borderline, right? Okay? Now, what if I change that to 99% confidence? What's gonna happen to my margin of error?
It's gonna be
It's gonna be bigger.
bigger.
It's gonna get bigger. What if instead of 12 cars, I had 120 cars?
The margin of error would go down.
Margin of error would go down. So there might be, should we do that really quickly?
Question.
Okay, yes.
So can you increase the confidence interval by increasing the sample size?
If you
So let's say instead of
If you
doing,
increase the sample size, holding everything else the same, you will decrease your margin of error.
no, yes, the margin of error will decrease.
Margin of error will decrease. Okay, so I'm gonna change this 12 to 120. So remember, it was 55.82, it's now 58 to 60. Is there evidence for speeding now? Definitely. They're
Yeah.
going 4 to 6 miles an hour over the speed limit, right? Does that make sense? So all I did was I changed my sample size. If I changed my sample size back and I changed this to, what was 99% confidence? 99% confidence was 2.575. So 2.575. Okay, so I've got 12 in my thing again. And I'm gonna change this back to 12. And 2.575. Now, is there evidence for speeding?
Yes and no.
Not enough, right? Because 55 is in my limit. Some cars might be going as low as 53.5. They're not speeding. What's happened to my margin of error when I increased my confidence? It became much bigger, right? I went from, what was the margin of error? Oh, that's a good question. What's the margin of error here?
7.
It's just this piece here, okay? If I get rid of my X bar, here's what I'm gonna do. I'm gonna copy this. If I get rid of my X bar, it's just the last half of the equation. Everything but the X bar. My margin of error in this case is almost 6 miles an hour. Okay? So I'm adding and subtracting 6 miles per hour, essentially. Does that make sense? All right. I want to do another one, but Oh, I think there is one. There's one more formula I forgot to give you. I'll give you that one really quick. Okay? Now, the question that most people are gonna say is, well, how big does my sample size have to be? Focus. Come on, focus. I hate this thing. Anyway, it's going to be n equals z sub alpha over 2 times sigma over e. E is your margin of error squared. Okay? So the idea here is how large the sample to be within 2 miles per hour margin of error at 95% confidence. Okay? So let's figure that out really quickly. So my n is going to be, if you look at the chart, this is going to be 1.96 times margin of error is 8 divided by, or sorry, that's your standard deviation. And I want to have 2 as my margin of error.
Oh, is that what E is?
What's that?
Is E margin of error?
E is your margin of error. Okay. In this case. Okay? So if I plug this into my computer here really quickly, n equals 1.96 times 8 divided by 2, this entire quantity squared. This gives me a value of 61.46. So n equals 61.46, but you can't count 0.46 of a car, can you?
No.
So what should that round to?
61, no, it'd be 62.
It should round to 62. Okay? So your n needs to be at least 62 cars. So if you would do that, you're going to have a margin of error of just 2 miles per hour. You're going to be 95% confident. Okay? So this is the other formula that you'll want on your homework. You'll probably have some sample size problems. Okay? I will post this video. Homework is due Tuesday. Test is in-class test. We're going to meet in our regular classroom in the science building on Tuesday. And so see you all on Tuesday. And don't forget to take the test Monday in the testing center if you want to take it for free. Okay?
We have to know how to do alpha, or that's just like reading to us.
Alpha will generally be given to you. If I forget to give it to you, which I will do, assume it's 95%. 95% confidence in alpha will be 95%. Okay? See you all on Tuesday.
What chart are you using? I like looked down to write this down, and like it was like up in that. Is it 1.645?
I use 1.645 here.
So how did you get that? What chart?
This chart right here.
Is it? Oh, it's on the standard room illustration. So it'll let us do it on the Macmillan, right?
Yeah.
Okay.
I think so, hopefully.
I just like looked down and when I looked back up, it was gone. Or it was there. So, okay, good. Yeah.
Okay?
So.
Yeah.
I guess so the X bar plus or minus the Z, and then how do you say it?
Alpha over 2.
So how did the Z and alpha go together?
So remember when I did the 68, 95, 99?
Right.
If you're 95% confident,
Right.
how much are you unconfident?
Yeah. 5%.
5%. So your alpha is 0.05.
Okay.
You've got 95% here, you've got half of your alpha here, you've got half of your alpha here.
Oh, okay. So then the plus or minus is the plus and minus.
Right.
Okay. Cool. And that number will always be given to us. That's just something.
What's the number on the chart?
Okay. Cool. So we ever have a problem where it's like find
Find the 75, so 75% confidence interval is not on your chart. Okay. We're still recording, believe it or not. Well, since you asked that, I know we're out of time. I have a class that started here. Now, if 75% is not on my chart, what would be my alpha if I'm 75% confident?
1.25?
0.125, yeah, 1250. Okay? So if you wanted a 75% confidence interval, what you have to do is you have to look at where is 12.5% on this chart.
So you would find it not.
So you're gonna have to find it here. Where's 12 point, oh, look at that, that's pretty close.
Right, so
What's
negative,
the z-score associated with that?
negative 1,
Negative 1.155.
cool.
And because it's
Okay.
symmetric, you're gonna have 12.5% at positive 1.15 as well. That's
Okay.
where you get the plus and the minus from. One's a negative z-score, one's a positive z-score.
Oh, okay, cool.
Okay?
Awesome. Thank you.
So that was good. I wanted to mention that since you asked me, and we're still recording.
Yeah.
That's bonus material.
Yeah.
Thank you.
Okay?
Okay,
So
so,
this recorded?
No.
Okay, we're moving this on.
Wait, never mind.
You recorded?
Yeah, I don't know. So I don't understand.
Nice.
So if you increase the sample size and with speeding sample example, if you instead of taking the average of 12 cars, you take the average of 120 cars,
Right.
then you margin of error decreases.
So think about what happens is you're looking at this, when you get a big number in the denominator, what happens to this overall number? So 1/10 is 10%, 1/100 is 1%, right? So the bigger your denominator gets, the overall fraction gets smaller. Does that make sense?
Yeah.
So that's why a bigger sample size is gonna make the margin of error small.
Okay, so if then if your margin of error is smaller, why can't you say I'm 99% sure?
Because you haven't changed your confidence level. I'm only changing the n, I'm not changing my confidence.
Oh, okay. That makes sense.
So
Cause I
confidence remains the
wasn't
same.
getting that, like, cause if,
Yeah.
oh, that was,
So
if we
if
kept-
you
we
only
kept it-
change the n and you keep your confidence level, yeah. Or you can change your confidence level and keep your n. Or you can change them both, but then, it's hard to figure out what happens.
Okay, I understand. I just couldn't figure out why we couldn't increase the confidence interval if we were increasing the sample.
No, you can, but I don't know what's gonna happen like this. Because increasing this is gonna make it bigger, increasing this is gonna make it smaller. If you change both of them at the same time, well, it depends.
So you can't say I'm 99% sure by just changing the sample size. You also have to change the
The
confidence interval
Yeah.
to get the right.
Confidence level.
Yeah.
Okay. All right, great bonus questions here. I'm sure this off
I think.
oh, hold on, yeah.
now.